Hello, in this video I'm going to be continuing working on my Rust to .NET compiler module. It basically enables the Rust compiler to turn Rust code into .NET assemblies, and in this video I am going to be working on fixing some bugs. I have recently started fuzzing the compiler, so I started creating random Rust programs using the compiler test tool called Rustlantis, and I am currently working on fixing the issues I have found. Here I have generated like around 100 random not small, like 4,000 lines Rust programs that they basically stress every single part of the compiler, and because of that they are very good at finding bugs. As you can see, there is still quite a bit of tests failing. I have made some significant progress because 2 weeks ago none of those things worked, and now after 2 weeks like around 30% of them work, so that's kinda good, but still there remains a lot to fix. I have actually uncovered some quite interesting things while fixing some of them, because one thing that I discovered is that casting from floating point numbers to integers works very differently in Rust and in .NET, because in Rust when you cast from a very large integer, like here we have a enormous integer, from a very large floating point number, if you cast from a very large floating point number to a smaller integers type, the Rust will saturate. So it will, if the value of the floating point number is higher than the maximal value you can store in the integer type, it will set it to the maximum value. And .NET behaves quite differently, because instead of that it wraps around. So if I here have some random number, instead of saturating it, it will it shouldn't probably be divisible by 2 otherwise. Okay, that's kind of suspicious. Okay, so here you can see basically this works very differently than in Rust, because if this value is floating point value is too big, instead of clamping it, like instead of saturating the integer number, it will wrap around, which is kind of unusual, and I had to basically mimic the behavior of the Rust compiler, which will, instead of like wrapping around, it will saturate. So that's a small difference in theory, but it really makes in the end it's quite noticeable, like, and it led to some code behaving differently in Rust and in .NET. So today I have, as you can see, a couple more tests, and I will pick one of them, and cargo test fuzz 80. And here, after it runs, it will return to me the output from the .NET program and the output from the Rust native program and the Rust running in the .NET runtime version. And if I compare those two versions, there will be some differences. And then basically today I'm going to be trying to find the exact cause of those differences. So here you can see this basically prints the values of some variables. This is like the test program. Basically it prints does some calculations and prints the results, and here, as you can see, the results are quite different. And okay, so this seems relatively easy thing to try to find the cause of, because here the only difference is that the Rust native version has a false value here and the .NET version has a true value here. So now that we know that in function 16 the local variable number 31 has a different value, we can open this particular example. Here it was the 80th test, so you can search for as 80, and here we can see the generated source file, and we can search which function was it again, function 16. So 16 here, and at the very bottom of this function, yeah, those things get printed, and here the issue was that the value number 31 is wrong. The value of the local number 31 is wrong. You can see this local here. So now we can slowly go. Okay, so we can see that this value is the result of the comparison between the variable number 27 and the variable number 13. So this probably means that those variables also, either it means that the comparison is wrong or that the value of those variables is wrong. So we can copy this particular yeah, we should be able to here to copy this thing. The what you see here is not normal Rust code. It is mir. Mir is the internal Rust compiler representation of your program, and this is what the fuzzer I'm using produces, because this allows it to test different parts of the compiler, and it allows it to test the parts of the compiler that would not be normally tested, because some of this code is not like the code that's normally generated by the Rust compiler. When it turns your Rust program into mir, this allows it to test mir directly, and because of that it's kind of easier to debug stuff. Mir is also what my CodeGen backend, my Rust compiler module, consumes. It gets mir from the compiler and turns it into .NET assembly. So that's also why I'm using this particular fuzzer, because, well, it's far easier to debug mir, because, well, to look at mir, because mir is exactly what I'm consuming. So because mir is what I am normally using. So here I am going to split this basic block into two pieces, and I'm going to use this call to the dump var function. The dump var function basically displays the values of different locals. So here I'm going to switch it around to show me the value of the 31, the local number 31, the local number 27, and then we can see why the value is wrong, and from then either we'll discover that this comparison has miscompiled, or that the miscompilation is somewhere further along. For example, if the value of the local variable number 27 was wrong, then we would repeat this process and go up till we find the exact failure point. Really not that hard, but I believe it's kind of interesting because it showcases some parts of the compiler. For example, this showcases the parts of the compiler that you normally don't see. So yeah, number 13 then, and this, the last thing we can keep unchanged. Then we will basically run this fast test again, and then we'll copy its results again and check if those local variables number 26 and 13 are correct, or if they are not. And then we will try to look at the generated .NET assemblies and try to figure out, oh my god, why this thing here failed. Okay, so let's copy that down here, and we'll have a comparison and see. Okay, so why didn't this get printed? It should have. Okay, so it was probably printed somewhere earlier. Or was this no, this should have been called. Why is it not called? From BB, yeah, so this. Oh, this is not. Yeah, because this goes back up here, so this is not the place where this miscompilation is, because this branch is basically not taken. Those basic blocks consist. They make up the branch that's never taken, because normally it jumps directly to basic block number 10 and skips the basic block number 1. So this was not the root cause of the problem. Here should be the, yeah, here is the real cause of the problem. No, did I go to the right place? Oh, so yeah, the only thing is this basic block was skipped because this match statement basically had a different value and didn't jump to this particular block, so we basically have to run this test again. Okay, I hope now this will work. Okay, let's clear this difference, and so this is the change.NET version, and this is the Rust native version that shows us how this is supposed to look. Two additions, so there are two differences, but the differences are not with the difference does not come from the value of those particular of the numbers compared. It only comes from the comparison. So from that we can deduce that the real issue is in the comparison. I think I might have a rough idea what is the exact cause. Okay, so first of all, what's the type of the local number 27? Okay, so it has the type of native unsigned native integer. And what is the type of the value, the local variable number 13? So both of them are unsigned integers, and we can so now we can turn this into a smaller test, and we can check if this test will still behave incorrectly. So we can now separate it into a test. Okay, so here I will copy the file that tested addition, and I will create a which operation were we testing? Less than, I believe. Okay. Yeah, so greater than. Okay, so we will now have a test that will check if greater than works correctly. Okay. As you can see here, I am not using assertions, which may seem quite unusual at first. I'm using my own custom, instead of using assert aq, I have defined my own type, like my own not type, my own macro, because well, when an assertion fails, it first has to do some formatting, and it because I don't support formatting yet, because formatting in Rust is a very complicated process. I am using a much simpler macro that uses the .NET interop layer to call console.writeLine, and this basically, instead of using the built-in Rust formatting, this basically means that there are less failure points, because, for example, if the formatting was wrong, then it could mask the real problem. So here I want in my tests to use as little Rust as possible, because those tests have to check if Rust works correctly. And you probably shouldn't be testing the language in which you are writing the test. It's kind of since I'm testing very basic things, if this is wrong, then a lot of other stuff would be wrong, which means that the result of formatting would be unreliable, so it would be less than useless, because it would could only confuse me. Okay, so first we have a value A, we have a value of B, and we want to check if A is greater than B. And native Rust tells us that it is not, because, well, this number is obviously quite a bit smaller, and yeah, and they are of type usize. And we want to check if A is greater than B, and the result of this operation should be false. So now we can add this test to the testing harness. Here I have like a lot of automatic tests. Those macros basically call my compiler, like set up the compiler to use my compiler module instead of the standard .NET compiler, instead of the standard native Rust compiler. And they also like set up the runtime and do things like that. So that's why I'm using make macros to arithmetic, and this was greater than. Okay, so now we should have a test, and we can just call cargo test greater than, not that, than. Okay. Oh. What's the issue? Allow. Okay, so this is allow. Okay, so. Okay, yeah. So in release mode, the Rust compiler, I think, optimized this comparison, like made this comparison at compile time. So we'll use black box to ensure that it is not allowed. We will basically tell the compiler, no, you are not allowed to optimize this out. And now it fails in both cases. So now we can also, like, if we go here, we can. No, we already know that one of those values is false, so we don't need to do much else. Yeah. So now the question is, why does this fail? So we can open this is the .NET Common Intermediate Language. It's basically a human-readable version of .NET assemblies, and we can search for the main function. And okay, we first load a constant number here, load a constant number here, compare greater than, and then we branch based on the result of this operation. We can also, one of the things I use quite extensively for debugging purposes is I decompile my .NET Common Intermediate Language back into C# because it's kind of easier to see what went wrong. And I also sometimes look at what does the C# compiler do. Okay. Native integer greater than native integer. Okay. Why is this negative? I do convert them to unsigned native integers. Why do you think I'm comparing signed integers? That's a bit. Oh, I think I know what has happened. Is there like a... Oh, Yeah, I should have been using the unsigned version of this comparison. This doesn't matter until you have like very, 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 very large numbers, but in this case we had a very, very large number, and this is why you should test stuff. Because you never know what kind of stupid stuff you have done. Okay, so basically I have to add... I think I didn't have this particular... Yeah, so I have to add an information that about... I have to add a new opcode to the to my enum that represents a common intermediate language operation. We'll search for... Right. Let's see. Where are you? Greater than, okay, GT. Okay, so here we'll basically create a copy of... I think we should do this, and the exact same issue will also happen with less than. Okay, so if the open... Turns out this was a really simple, stupid mistake. Should be very, very easy to fix. Okay, so now we'll have to... this particular function is used to... it's called stack diff because it calculates the difference on the evaluation stack of the... because .NET, the common intermediate language, basically works on an imaginary stack. This is not like a real stack in software. This is like the way the basically common intermediate language is kind of like an instruction set for some imaginary CPU that's then turned into real instruction by the JIT compiler. And this function is used to calculate how each op affects the stack, because I use this to detect miscompilations in my code. I have like a couple layers of tools to detect miscompilation. This particular one is very simple and rudimentary. It basically checks do I ever under or overflow the stack, and does the stack end up at 0 at the end of each statement, because because each Rust MIRI statement is independent. The stack should be start at 0, and there should be 0 items at the beginning and 0 items at the end of each MIRI statement. So because of that, I can like detect some very basic errors, like I don't know, I have missed an instruction, not added an instruction, I have not loaded something on the stack when I should. Yeah, so here I basically have to add support for the unsigned variants of those two ops. So I will also have to add the support for them in the exporter. Greater than. In the future, I probably should add support for them in my optimizer. It's it's also quite simple. It basically works by replacing certain combinations of common intermediate language operations with equivalent ones, and by doing that, it slowly simplifies the program. For example, if you have a comparison and then you check if this comparison resulted in a 0 or 1 and branched based on that, it will replace those two ops with a one instruction that does the exact same thing. But it is slightly better for the JIT to, and for the assembly size on disk to use less, to like have less operations but more specialized ones. It basically makes reasoning about the program easier for the JIT compiler, and it makes it faster because it can the final compiled code, the final JIT compiled code faster, because the JIT compiler can make better decisions. Okay. So now that we have, what's your problem? Where is this issue? Oh, I have accidentally deleted less than. Where are you? That was kind of. You have to make mistakes sometimes. Okay. And now I basically need to change the way here in BNOP the way the binary operations are handled. Okay, yeah, so greater than unchecked. And for unsigned numbers, oh, that's kind of great, because for unsigned numbers I already separated them here, so I can just do greater than unsigned. Here integer greater than signed. The question is, are Rust characters signed or unsigned? Not integers. Wait a second, I don't think you can compare like the char type anyway. I don't think you can do that. I will have to check that once again. Okay. Yeah, for floating point numbers, well, they are always signed, obviously. Pointers? 2. That's kind of interesting. If I compare 2 pointers in Rust, are they signed or are they unsigned? Okay. Here. Okay, so pointers are unsigned integers, so here I will have to change that. It should emit greater than unsigned. Okay, good. I think like those operations for booleans and chars are this implementation is left over after I copied the equality operator to change it into other comparison operators. I think they are not needed ever, but I may be wrong, so I still kind of have to. Yeah, because what would even checking if a boolean is less than mean? Yes, I think those are just leftovers after I copied some code around, and they should not be there. Okay, so pointers are unsigned, and well, unsigned integers are unsigned, as the name suggests. So now I should be able to check greater than and see if it works the way I want it to work. Oh, and now it works. Now let's test the particular fuzzing. Oh, it works too. I'm kind of curious, did it fix any other tests, or did it just fix this one? Oh, that's weird. Oh, something happened. Oh, I have only spent 30 minutes on this. I think I can spend a couple more on, and maybe I will manage to fix something else if it's as simple as this. Yeah, Fedora is kind of freaking out because the .NET runtime is constantly crashing because of unhandled exceptions. Oh, 21 passed. Why 21 passed? Did I mess something else up? Let's run all the stable tests and see. The basically stable and unstable. All it does is the stable tests are the tests I run on GitHub Actions automatically, and those are the tests on which I consider a regression. Not all of the tests work, and I want to only know about regressions. This is my way of detecting regressions only. Oh, but it seems like something has... Okay, so something has panicked? That's kind of... Oh, that's kind of... So those were needed. Huh. What for, I wonder? But, yeah. So it was needed. I'm still not sure for what exactly are they needed, and what does a Boolean value meaning less than something mean. Learn something new every day. And now I should have no regressions. I hope so. Okay. Okay, and among the fuzzing tests, there are still quite a bit that fail. No, I made some progress today. Not as much as I... Okay, so now 32 out of 125 works, so that's slightly more than I had before. Before I had 29. And this is 100 and... no. How many? 32 out of 125. 125, that's... 25%. A quarter. Okay, so here, this is a much more complicated issue. This message basically means that I have a more serious miscompilation. This basically means that I did something that the common language, like the .NET runtime, doesn't allow. I did something that means that makes my common language intermediate representation invalid. I don't know. For example, I tried to add objects, which doesn't make any sense because objects are, well, they are references, they are pointers, but you are not allowed to add objects directly. You have to call a function to add things like objects. Okay, so let's search. Is there something else that's relatively short-ish? Oh, let's try 40. I am feeling lucky. Yeah, 40 seems like it's not going to be too hard. Yeah, after I squashed the most of the big bags, the ones that remain should be more self-contained. There should be like one bag per a failed. No, this should not go here because it's not the original, it's a changed version. And here, if I copy that, yeah, I hope. Oh my god, what is happening? Want to copy. Hope I copy the right thing. Okay, so there are not too many differences, and they look kind of related to me, at least. Okay, so in function number 12, there is a small difference. here this number is signed and here it is unsigned. To me it seems like a failed cast probably, or once again another like kind of self-contained bug, because the other ones seem like the like a snowball effect, like one thing fails and if an operation use this as an input, it will fail too. No, I wanted to search for which test it is. It's test number 40. 40. Okay, here we go. Function 12, and I'm interested in local number 6. Okay, so here, let me see. So to 6 is assigned the value of 20 plus 20, and here you can see that the value of 20 was wrong too. So that tells me that the issue is really with 20. What even is 20? Okay, so 20 seems to be, so it seems to load the, so it seems like this function returns an enum and it seems to be loading it's from its first variant, it loads the first field. What kind of enum is that? Is it yeah, it's one of the procedurally generated enums. So this particular thing, I have a rough idea of what might be the exact cause. I'm not very, yeah. Basically, right now I don't set the layout of enums properly. Like I leave with all the types in Rust have very specific layouts. Like for things like normal structs, where is a good example? Oh, here you can see I am providing explicit layout to the .NET runtime in bytes, but I do that for enum. I tell the runtime where the specific variants of an enum are, but I don't tell it how to lay the fields of an enum in, like how to lay them out in memory. And because of that, I believe I may have the runtime does its own thing, like it decides by itself where they should be, and I think it may differ from the real place where they should be. So that's unfortunate, but I have tried fixing that. But I basically need to ask on the Rust compiler developers like how to get the layout of the variant of an enum properly, because it's not that simple. Like I haven't managed to do that myself yet. Like I tried to do that yesterday, but for some reason I only got some of the fields, so I will have to look at how to do that properly. Maybe there is an easier thing to fix. That doesn't involve enums, because enums are kinda a whole mess. Like I have got them in a much better state right now, but still they are so complicated that it's very easy for a small bug in layout to lead to absolutely catastrophic consequences. Like I had a very annoying, a very weird bug which a miscompilation. I spent a lot of time trying to find its exact cause, and it turns out it was just related to layout once again. Basically I kind of mixed up the order of some fields, and because of that they overlapped, and a pointer was set to null indirectly, like because another field was laid out on top of it. Because of invalid layout, a pointer was set to null, and I was referencing a null pointer, and I was scratching my head trying to figure out, like, I'm not assigning a null pointer. How does this suddenly become a null pointer? It's not a null pointer at one point and suddenly now it is. And it turned out it was just a layout issue. Those are like, they're not too hard to fix once you understand what's going on, but I basically now double and triple check that everything with layouts is 100% correctly by the book and there's no deviations there, because layouts will screw you over without a second thought. Okay, so here the local variable number 2 has an incorrect value. And is it a local variable or is it an argument? Because if it's an argument, that's... Okay, so it's just... No. It is a local variable. I don't like that, because it means that it comes from somewhere else. But is this... Okay, so it should have this value, but it's 0. Why is it 0? So now, no, I want to go to the definition of this function. I will check if this particular argument, like, where does its value start to differ? Do I assign to it? Okay, no, because this once again is a branch that's not taken after a match statement. Okay, so I should probably also look from where does it go to the 18. Okay, so it jumps from here. Do I ever assign to 2? To the local 2 here. I assign to local 5, which is the other local which has an invalid value. So this once again tells me that at this point, at this very point is... Okay, no, I don't assign to it here. Do I? Because this is not taken, I think. No. Just like jump back? I don't know. It's kind of convoluted. Okay. So here I set the 2 to the obviously and the value of 20 and 5. So I need to check, do those have a correct value, or is this once again a case of a simple binary operation not working as it should? Okay, so 0 here, no, that here, and that here. So basically I'm defining a new basic block here, to which I will then return. Okay, I want to know what is the value of 2 at this point. Is it already incorrect? What's the value of 20? Because that's kind of important. What is the value of 5? And the last one may remain as 2. Okay, because if those have correct value, then I know that the issue is with the AND operation. If they don't have a correct value, then once again I go up the function and try to find the very first point at which the result differs. I hope this doesn't cross a function boundary, because that would mean that I will have to test another function. I generally prefer, once again, very simple cases in which I can... So this is fast50, okay. I'm not sure in which terminal window I have the results. I will just run it quickly again. Here. Okay, so this is the broken .NET version, and yeah, so basically right now a lot of work on the project is just looking at those comparisons and figuring out the exact cause of the difference. It's kind of, on one hand it's a bit more, I don't know, repetitive, but on the other hand I always like discover some new weirdness. Don't tell me it didn't print it. Wow. So was this once again something that was not taken? A branch not taken. Really? That's kind of annoying. Oh, is it a not branch that's not taken? Okay, so 1 is set to 5 here, so it should be jumping to the basic block number 8, and this basic block will go to 9, which is here. So I should see this value. That's kind of weird. Oh, maybe it's before a call. Yeah, it's before a call to function. No, there's like a call in between them. Yeah. So I will have to search for -0. No, -0. Okay, here. Okay. That's very interesting because the value of 2 is correct here, and the value of 20 is correct here too, and the value of 5 is correct here too. So now I know that it's somewhere downstream from this point on. So where do I go from here? I match the 5th field of this, which is set to this crazy value, so then I jump to the basic block number 11, or I set 2 to a value here. So I could change this to add yet another check here, and I will also check this thing number 9. It will be kind of interesting to get it, to know its value, because to me this seems like the point at which it might have broke. If it broke, oh, that's very interesting. Did they do something very stupid here? If I delete that, unreachable reached. Huh. Only to T1. So this seems to... maybe it impacts the way it's optimized. That's bizarre. Yeah, I probably should like do those kind of checks on the debug version, because currently I'm looking at the release version. It's basically kind of easier to analyze seal after it's optimized. I will first try one trick. Yeah, is it? I believe that's the configuration variable. What this should do is it tells my compiler module to insert additional things that will make the .NET runtime always initialize all local variables to 0. So basically because of that, yeah, always init locals. Where is it? Oh, here. Yeah, so basically if you set this to 1, it will first initialize everything to zero before anything happens. So because of that, you have no uninitialized memory, and everything will behave in very predictable ways. If you have like if you ever access memory that's not initialized, okay, that's kind of interesting. Null reference exception. Oh, I think I know what is happening. At least I have a rough idea about what's happening. So now I'm printing something that has no value yet. Okay, but I'm interested in 2 and 9 only, so I can change those to print 2 and this to print 9. Or maybe 9 is not fully initialized yet, and it contains, for example, a pointer. Because if something contains a pointer, then when I try to print it, I will go dereference that pointer to get the thing behind it. Okay. Yes, I suspect 9, maybe not. Okay, if I delete this, will the null reference exception still be there? Because maybe I'm just accessing I'm accessing an uninitialized variable. This is kind of I would like for this to be slightly simpler. Okay, I can do that and only check this particular field I'm interested in, and it should now work. Okay. It's kind of worrying that that there was this, that I reached unreachable. Unreachable is basically like the Rust compiler has inserted an information that something should never be reached, and I reached it, which means that there is another issue hidden somewhere. Like this triggered it, but it's the fact that it wasn't triggered before doesn't mean that it doesn't exist. It only means that I haven't encountered it. So that's something to keep in mind. I'm sure that that's the exact reason why I'm doing fuzzing, because like I have discovered so many issues thanks to this. Okay, so you see that only three. Really, you see only three differences here. What kind of differences are there? Yeah, so this value is wrong. Did it skip something? Oh, that's very interesting. Yeah, so it seems to somehow impact the way stuff is getting optimized. Oh no, because the value of 2 is still correct here, and the value of 9 is correct here, which means that this difference is happening somewhere further downstream. Where could it even be happening? Oh, did I seriously by accident miss something very, very obvious? Yeah, obviously here it's set. So, yeah. Sometimes I do some dumb stuff. I hope I'm not too loud. That might be a problem. Okay, I will try to be a bit quieter. It's kind of late. Okay, here. Is there yet another difference? No, there is not. Let me see. Okay, so did I insert this here? Yeah. Okay, that's kind of done. So 20 0 2 2 2 5 5. Is this once again? Yeah, this is the block that I'm skipping, so it should have no impact. Okay, so here should be the real cause. It's no, because this block 2 returns. So where does all of this get messed up? I'm not really sure. I will find this issue at some point. I'm bound to accidentally stumble at it. What? Are they any? No, so it's not different at that point. Really? Or am I just skipping this basic block too? No, yeah, here this basic block is getting skipped too. So this can't impact the value of this. So, okay, what is picked exactly here? Okay. Okay. It's jumping directly to basic block 18. Huh. Rarely have I seen something so... At which... Oh, let me check if it's... No. No, let me check if this is correct at this point. Okay, let me cut that out and paste it in here. Don't tell me it was this close all along. And I hope it's not yet another layout issue. What is 5.0 set? Or there is a difference already here, so that at least tells me it's somewhere here, and that the value of 5 is already changed here. Is this really discussed? If it's this, then I'm going to be mad. If it was there all along, no, because this is the path that's not taken. I have, okay, so here I set 5 to the value of this. Okay, so let's set one of those to 23 and check if it's correct, because if the difference is here, that it may be, then it's either to this being different or this. Yeah, so the only way is either the bit shift is wrong or this is wrong. It may be the bit shift. What's the weirdest thing I've... Oh! So I'm displaying... Oh, I understand what's happening. I think the local variable number 23 is contains an UTF-8 character, like Rust character, and it's has an invalid value, and because my test harness like detected that in the output there is an invalid UTF-8 character, it's like I assume this should never happen, but in hindsight, yeah, I probably should not have assumed that. Okay, this should be a relatively easy change. Just to find somewhere. Yeah, somewhere here I have my test function. Is the where the okay? So panic here. Let me go here and she. Oh, that tells me a lot. No. Okay, at compile test 37. That tells me far more. String from UTF-8, I can just change this to lossy. Yeah, I'm kind of potentially. Yeah, I should. And it's taking a reference here, so it's slightly less efficient. And here I have to call to string. But the the benefit of doing this is that I can still look at the error messages even if they contain non-UTF-8 characters. Let me wait, and it's changed. Yeah. Okay, so it's probably just that. Oh. Compared to the previous one, this one is quite a bit more challenging to figure out. Is there... Oh, this difference is... What has happened here? Oh my god. That's really, really bizarre. From where does this character come from? So I know one thing I know is that the value of this local variable is already wrong at this point, which is in itself quite a bit of valuable information. Yeah, and here are the random characters, but why is a random character here when it should not be? I'm sorry. Okay. I print it. Yeah, so print it here. But really, I'm interested in the value of this and this. So I could, in theory, just print the value of those things. Even if my formatting kind of fails, I still should be able to kinda at least get some information. Because I'm really curious if there is a difference here, like in the value of those things, or the difference is from this binary operation. Because that's really the. Okay, I wanted to change this to 23. Okay, and here. No. Okay, and I should now be able to compare those two and see what's happening there. Yeah. On the other hand, like because of how complicated this seems to be, it's good to get this out of the way now rather than way in the future. It's good that it got caught, because I can't imagine trying to understand a miscompilation like some large library and something like that. Okay, so there are now 14 differences, so there is. So, okay, so I now know that the difference is in the value of this thing, and it is set to the exclusive OR of those two things of the value of the local number 3. Which a good thing is that it's set to a constant here. This means that we are at the end of our journey. Either this constant is wrong, or this XOR doesn't work properly. So that's very good, because it means that we are very, very close to the real issue, like almost touching it. We're almost there. And here. I wanted to check if. Did I do something wrong here? I wanted to check if the value 3 is right. Why does it tell me about the value of. No, I changed this to print the value of 3. So this should be 3, then 23. Did I not run the test again? Let me also first clear, so it's harder to copy the wrong thing. Okay, those kind of. I didn't save. Well, those kind of issues are really the most annoying ones. The ones in which, like, you didn't fail because you lack skill, you failed because you are an idiot and you have overlooked something very, very simple. Like, I had a really annoying bug once that it turns out it was not caused by something being radically wrong like something I didn't understand at all. It was caused by me not being able to read. I have read unsize as usize, and because of that, instead of a cast causing something like an array to lose its size, so be converted to a slice. So an array is sized; it has a fixed size, and a slice does not. So an unsized cast will change a pointer from an array to a pointer to a slice. A usize cast, which is what I read, instead of unsize, would mean casting a pointer to I usize a native unsigned an unsigned integer that has the same size as a pointer, and because of that I handled this cast completely wrong, and at the end it turned out that it turns out that this whole time I had a cast that was completely wrong because I misread something. Okay, so this seems quite interesting. The issue is with... Okay, so let's let A, then we can have let B equal to A, XOR A. Yeah, I'm XORing something with itself. So this result should always result in a 0. How can it result in anything else than a 0 is beyond me. Yeah, and here we can see why did I copy stuff in the wrong order? Why is there 744 in Rust? Am I going insane? What? This is XOR. Exclusive OR. If you exclusive OR something with something, it should always result in a 0. Why did I copy the stuff in the wrong order? In the Rust output, let me copy the Rust output once again. Did I somehow miss? No, I couldn't have. What? Okay, once again, I replace this with this. Find the difference. What is going on here? I have never understood something less than now. What? Okay, let me sanity check. Maybe it's a bug in my testing harness. Or maybe it's UB? Undefined behavior shouldn't cause that. Fast 50.rs, not .rs, plus to fast 50, and okay, let me then open this file. Now let's review one step further. Did I mix something up like significantly? Yeah. No. Oh, no, it's 0 on the Rust side. Okay. That's... Yeah, it has the correct value on the Rust side. I just didn't look at this right. Yeah. Yeah. Exactly, it has a value of exactly 0 on the right side, and it has a value of something else on the .NET side. Oh my god, for a second I thought I was going insane. Yeah, after 5, okay, I just... Yeah, okay. I... Once again, reading... Why? Okay, so the result of binary XOR is incorrect. This should not be that value. Definitely under no circumstances should it ever be a value other than 0. So now I can get this test and turn it into add yet another thing to my test, arithmetic tests. Oh my god. Oh. Copy and paste. Okay. And this should be 0. And if this will probably miscompile. Oh my god. How does this XOR result in anything other than 0? What kind of mistake would even lead to that? Did I accidentally closed something I needed? Oh well. That's why you always double check. Test now. Okay. Well, now that's a bit long. Okay, so as you can see, XOR is broken. And I suppose it will once again turn out to be something trivial. I can even search for XOR. Did I accidentally use all instead of XOR or something like that? Yeah. Load local. Why am I checking if there are... Is the Rust compiler optimized? No. What's happening here? Where is XOR? Let me check something. Okay, so first of all I will disable optimizations. My optimizations, because they are quite often broken. Optimize CL equals to 4, 0. What do you mean by that assignment? Okay, but still it should be now slightly easier to read this. No, oh, I was looking at the wrong function. Main. Oh. Yeah, main is here, and there should be a XOR here somewhere, but there are no XORs inside, which means I did a big mistake. What do you mean unexpected end of file? Oh, because this is the very first. Okay, why I'm checking for inequality instead of doing a binary XOR? Is this once again some kind of like something I did copied wrong? Yeah, that's why I should have more tests. And it was kind of a big mistake to not. At the very beginning, testing was way more difficult, and because of that, bit XOR. binary XOR unchecked. Am I calling the wrong function? No, but bit XOR, binary XOR unchecked. Why is there equality there? And no XOR. Oh, what is happening here? I want to. Oh, maybe the Rust compiler has optimized something out, and now. Oh, I was checking with A instead of B. Right, that explains why there was no XOR there. And now this passes. Huh. So why does this XOR work and the other does not? Because the value of this thing is wrong. Because this should be 0. It is exactly 0 in Rust. And here it isn't, and it is not 0 in .NET. Okay. I will probably have to just go to sleep and look at it with a pair of fresh eyes in the in a couple days, because I feel like I'm missing something very, 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 very obvious here. Okay. I'm storing two constants. Yeah, maybe it's something with the. Oh, maybe it is something with the layout. Okay, maybe it is layout after all, because if. Okay, so first of all, the question is, like, what's the type of this? Like, okay, if I have some layout issues, then that would, but this is not an enum. If this is on the other hand, like, structs can still have layout issues even after I have like a lot of tests for layouts, but something still could have snagged through. Oh, I set 7 to address of this thing, but 7 is okay. So here 7 is read indirectly. Okay, this is definitely very, very bizarre, and I think it may be just a layout issue, which is once again why they are so painful, because you may have like a piece. I will have to like try to replicate this issue, but this to me just seems 100% like a layout issue. Yeah, I will probably spend some time separate this into like a smaller snippet and then analyze the seal. Common intermediate language, like the version. I am pronouncing it. I believe it kind of wrong. Like, I don't know how to pronounce it properly. Seal kind of seems like the sea animals, seals. Okay, anyway, like, I think this is a good point to stop. Oh my god.